things first. You need to understand the difference between a regular pyramid and a non-regular pyramid. There's a regular pyramid if the base is a regular polygon and the altitude has an endpoint at the center of the base. In other words, it goes exactly the same angle here, 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 and goes straight up. This point, that is the vertex, goes completely straight up from the center of the polygon. That's what makes it a regular pyramid. The fact that the base is a regular figure and it goes straight up. You could still, a non-regular could still have a regular base, but then slanted it a little bit. See how this one's kind of pulled to the side? You guys see the difference? So regular, as far as pyramids are concerned, and actually as far as prisms in general and three-dimensional figures are concerned, have to do with whether it's straight up and down as well. Can't be slanted for it to be regular. Does that make sense? Because what happens here is because this is regular, all your faces are the same. Same size. Think about it. This base is the same. It's going to go up here at the same angle. Aren't all these faces going to be the same? However, you look at this one, this face is not going to look the exact same shape as that one, is it? So that's why it's not regular. Okay. With a cone, it's kind of the same concept. Even though we don't call cones regular or non-regular, but basically there's a right cone and an oblique cone. See a right cone? It goes what? Straight up. Oblique cone is what? A little bit slanted, right? Okay. Now, as far as cones are concerned, or I'm sorry, as far as pyramids are concerned, and they're kind of a pain to draw. Okay, there's an example of a pyramid. We're going to make a regular one. This straight down to here, at a right angle, that is your what? Height. This right here, this is an important thing. It's a cursive L, and that means slant height. And when it's a right one, usually this thing cuts this in half. Okay? The lateral area of a pyramid is 1/2 P, capital P, cursive L. What does the capital P represent?
Perimeter.
Of
The
what
base.
though? Of our base. The cursive L represents the slant height. Now, the height, slant height, and half the side there, what do they create together? Right here. What is that thing? If I was to pull out just that two-dimensional figure, what is it? A right triangle. So you imagine you're probably going to use some right triangle stuff here, aren't you?
Yeah.
The total surface area is equal to the lateral area plus the area of the base. So you could say the total surface area is 1/2 what? PL plus B. Capital B is the area of the base. Now, why do we not multiply it by 2 here? Remember yesterday when we did prisms, it was L plus 2B. Why is this one L plus B? There's only one base. Okay? You guys got to remember that what we have are kind of some shortcuts. Guess what? If that was the height, you could still find the area of each of these triangles separately, add them all together, and that would be your what? Lateral area, would it not? Then if you added the area of this square in the bottom, that would be the total surface area, correct? What we have are some kind of nice shortcuts where we don't have to find the area of each of these four triangles separately to find the lateral area. We can use the formula 1/2 perimeter times what? Slant height. Okay. Cone. What's the difference between a cone and a pyramid?
It has two bases.
There's a circle.
Or
There's a space.
I'm sorry.
I don't believe two bases of the cylinder.
Or cone, yeah, cone's right.
Mm-hmm.
Gotta make a little ellipse there.
You scroll down.
That's your height, right? This is your what? Radius? What is this? That's L, isn't it?
That's your slant height.
Mm-hmm. What do you think? If you were to guess the formula for lateral area, what would you say? For a cone?
Circumference times height.
No, it would be 1/2 what? Circumference times what?
Height. Or L.
In a pyramid, we used what? Slant heights. What do you think we're going to use here?
Slant height.
Here's the deal, though. Your actual formula in the book, everyone look up here, is pi r L. Does anyone know why? Everyone look up here. Don't write, just look. Once again, follow directions. How do they get from that to that? Do you guys know the formula for finding the circumference? What is it? 2 pi what?
Yeah, 2 pi.
Oh, you're pretty much dividing it by 2.
What happens to this 2?
And it disappears.
Leaving your formula for lateral area is what? Pi r L. But they got it from doing what? 1/2 circumference times what? Slant height. Just as the, so really, in essence, the formulas are the same, are they not? It's just for circle, you use what? Circumference instead of what? Perimeter. Okay? So, to find the total surface area, what do you think you guys do? Total surface area would be what? Lateral area plus the area of the what?
Base.
But since we have only one type of base here, I can put a formula in there. The lateral area is pi r L. Plus, how do you always find the area of a circle? Pi r what?
Squared.
Everyone get out your red books. Has everybody got this down?
No.
How about now?
Yeah.
Let's look at number 2. You'll have to use the audio if you're looking at this online. So you write some of this down, but I will wait until I'm done. Okay. They want us to find, we're gonna find the total surface area. And we're gonna find the lateral area. What are we dealing with, a pyramid or a what?
Pyramid.
So it's 1/2 what?
PL.
PL. Find the total surface area, it's gonna be 1/2 PL plus the area of the base. What is our base? It's a what? Rectangle or square, isn't it? I think they say it's regular, so it's a square, so it's S times S. You know, each side, one times the other. Everybody all right with that? That's how we'd find what? Or it's plus B. You'd find B by going length times width, which they're the same, aren't they? Okay? All right. So let's start out with lateral area. Everybody look up here. What do you need? Well, to find the lateral area, you need this slant height, do you not? We'll call it L. And I also need the perimeter. So I need each of these sides, do I not? But if I find one of the sides, I find the others, don't I?
Yes.
Okay. All right. What have I been given? I've been given that this, now, what is,
45, 45, 90 triangle.
exactly, it's a 45, 45, 90 triangle. What do we know about the legs of a 45, 45, 90 triangle?
They're
Equal.
congruent.
So this one is congruent to this one. So if this is 8, what's this?
8.
Now, what did I tell you that this represents?
Right angle.
Halfway in between here, right? So if this is 8, what's this?
8.
What does that make each side?
16. 16 times.
So I can find the perimeter by doing 4 times what?
16.
My perimeter is what?
56.
64
Yeah.
feet, correct?
Where'd you get 4 from?
There's 4 sides.
Okay.
16, 16, 16, 16. Does everybody see that? Found that 16, this is 16, that's 16, that's 16. 16 times 4. Okay, what's the only thing I'm missing now?
Surface area.
Huh?
The lateral.
I have a number for this.
The,
I have a number for the length and the width, don't I? I can find the area of the base right now. What's it? 16 times what? What's 16 squared?
100. I think it was 3. I think it was 256.
Square feet. So I have the area of the base. I have a number to put in there, don't I? The only thing I'm left that I don't have is this right here, the slant height, correct?
yeah.
That's the only thing I have left. How can I find the slant height?
Oh, goodness.
Pythagorean theorem.
You could use Pythagorean's theorem, that is correct.
What's a simpler?
You could use Pythagorean's theorem and say 8 squared plus 8 squared is equal to, well, L squared, is it not? Would everyone agree? So it'd be 64 plus 64 is equal to L what?
128.
What would you do now?
Square root.
How do they ask our answer to be in here? They ask us to leave it in simplest
Round to the
form, or they
nearest
say use
10.
a decimal?
Round to the nearest 10.
Okay, so it doesn't really matter, leave it as square root of 128. Okay, so now I have a number for everything I need in these formulas, do I not? So my lateral area is 1/2 perimeter, which was what?
64.
Times the slant height, which is the square root of what?
128. So it's 32.
So I do that times that, then divide by what?
2.
2.
Yep.
Would you find your lateral area, what did they say to round to?
Here's 10.
Because you're just adding it to this, you could round that to the 10th right now. What do you guys get?
I got 362.
Is that what you guys got to the nearest tenth?
Yeah, and it's 0.
Is it 0.5 or 0?
0.3.
Okay, so the lateral area is what?
362.
The total surface area is 362 plus what?
B. 256.
Total surface area is what?
618.
Square what? You did divide by 2 here, didn't you? Yes. How come it's feet squared? Because its area is always in square feet. Because you multiply its feet times feet.
Mr. Stubb, how did you get the base? It's just confusing me.
Okay. When this is irregular, even though you're kind of at an angle here, right? It's understood that that is the center of the whole bottom, right? So this right here represents half the distance. It's right in the middle here, and it's right in the middle there, right? So when you found this distance right here, when you found it to be 8, you can move that to here, and you found that half to be what? So if this is half this distance, if that's right in the middle, then this is 8. What's this side going to be? 8. It just doesn't look like it because you're trying to draw a 3-dimensional figure on a 2-dimensional space.
So
So it's kind of slanted. But you see how this point right here is understood to be in the middle. So here to here has to be how much of that distance, of this distance? Has to be half of it. And since we're understanding that this is a regular pyramid, that means this is the same size.
Okay,
That's
so
the
you
same
just did,
size,
like,
that's the same
main,
size.
which is 16 times which is also 16.
Huh?
That's how you found the base was main, which is 16 times which is 16.
It's a square at the bottom.
How did I find the area of the base?
Yeah, shut
Yeah,
up, Sean.
yes, it's a, shut up. Yes, I went length times width because it was a square.
Okay.
So 16 times 16.
So you're saying the slant height bisects the sides over there?
Yes.
Okay.
And so does the what? The height. In the definition, as I told you guys, in a regular pyramid, this goes right to the center of the polygon. So meaning it's halfway between what? Here and here, right? And halfway between what? Here and here. The thing that throws people off on this is that because you're trying to draw a 3-dimensional figure on a 2-dimensional space, for us to see it, we kind of got to skew it, don't we? I mean, in no way does this distance look the same as what? Does it? In no way does this distance look the same as that distance. Maybe I just didn't do a good job. Maybe should have been more like there. You know what I'm saying? But because it's skewed, it's a little harder to see that. We have to understand that that's going right to the center, halfway between on each side. Okay, so that means if you find that side, you found half a side, didn't you? Does that make sense? And there's no doubt it's hard to see. There's people, I'm pretty good at visualizing things. There's people that aren't, people that need to write things down. For those of you that are good at visualizing things, it may be hard to understand why people have problems visualizing things, but my mom, for instance, is not a person who could ever visualize things. My dad is where I got my math ability from. This would confuse her because she would need to have the physical pyramid sitting in front of her for her to understand it. Does that make sense? And yes.
Why did you use the diagonal here?
Right here, we knew that this was 8, this was 8, so I had basically I had this triangle, this right triangle where this was 8, this was 8, and I knew that was my slant height. So I used Pythagoras there and there. Make sure and write down everything you need. Cones are pretty much about the same thing. Guess what you're going to be able to use there, son? Pythagorean theorem. But your key there is they're actually even easier, because what do you need? What do you got to have? The pi r squared, right? You need the radius. The only things you need there are the radius and the slant height. If you look at number 2 on the other paper, what kind of triangle do you have there? When you guys are done writing that down, we can look at it a little bit. Has everybody got that written down? Can I erase that up there? One good thing to always do with this, realize you're going to need the things in the formula. Putting things into the formula is not the hard part. It's finding the things you need for the formula with the information that's given. Okay? Now, what kind of triangle do I have here? 30. What's this got to be?
60, 90.
If you'll remember, in a 30, 60, 90,
S.
well, this is the slant height, not L. We're mixing variables up here, aren't we?
Yes.
But this is the one I need. It's actually the hypotenuse, is it not? It's going to be our slant height.
Yeah.
This is S, right?
Yes.
Then the longer leg is 5 times the square root of 3, right? The hypotenuse is double the shorter side, making it
10.
So here, my slant height is 10, and my radius is what? Isn't that all the things I need for the formula?
Yes.
Find the lateral area, it's what? Pi times what? R, which is what? 5 times L, which is? Find the surface area. It's basically 50 pi, the same thing I just plus the area of the base, which is pi times R, which is 5 squared. Okay? You'll find that when you get into higher level math, leaving things in terms of pi is actually much more efficient or a much better way to do it. Like I'm leaving out in the 75 pi because that's pretty exact. The lateral area here I'd have is what? 50 pi. But what do they ask for here in these problems?
Nearest 10.
They ask for the nearest tenth. So, hey, it's not that hard. You did it in terms of pi, just multiply 50 times, then press the pi button, press equals, and round it to the nearest tenth, correct? You guys can do that.
157